60 degree. So root locus will clearly say how the poles are going to behave given the poles and zeros as starting information. You will just be given how many poles are there, how many zeros are there, where are the poles located, where are the zeros located. So only with that information we are going to clearly analyze the behavior of a transfer function. Since root locus does not necessarily tell us all about the zeros, you see importance is given to poles here. So nothing extra is told about poles. So you have to do some extra work to find how the zeros are going to be very, very important. So I'm going to take this A of s, A or capital A of s equal to A of s by 1 plus A of s into f of s. Okay, so A of s is going to be the zeros, and the poles are given by the denominator equal to 0. So this can definitely you can use this condition and you can see how the zeros are going to impact the root locus path of your system. Next, we are going to see what are the frequency and time domain characteristics. So this is very, very important because only when you understand how a system reacts to time and frequency domain, you can get more parameters about the system from those analysis results. So we are going to see about what is the first order system, what is the parameters of first order system, second order system, what all the time domain parameters are there, what are the frequency domain parameters are there, how can we model them for application, what all the ideal values and practical values for those things, everything we are going to deal with this. So the following formulas are going to be for first order system. First order system means you are going to have only one pole, h of s equal to 1 by tau s plus 1. And the derivation is already, we don't have to derive the parameters here, so you can directly use the parameters for your analysis. So the rise time is given by 2.2 tau or 2.2 by omega h angular frequency, p naught equal to mp equal to 1 and tp equal to infinity. So all these are the parameters, and settling time is 4 tau, epsilon 1 is going to be tau, and omega p is going to be 0. And what is the meaning of all these terms? This TR is called as rise time. The rise time is the time taken to rise from 10 to 90% of maximum value. 46 you see, it is the both the step and frequency response are monotonic in pole system. Okay. 47 you see, it is the TP. What is TP? The step response, time taken for when the system reacts to a unit step signal. 48 you see, this equation is settling time. So how the system settles after reaching the final value. So it takes 4 times the time, 4 tau, it is 4 times the time constant value. Epsilon 1, it is a steady state delay. So how much when you give an input, the system will not react immediately, right? It will take some time. So that is going to be the time delay. And finally, omega p. Omega p is going to be the peak frequency response occurs at what frequency. Whether the frequency response occurs, the peak occurs at some frequency in between, or whether it occurs at 0, or whether it occurs at infinity. So that is given by the parameters. So these are the parameters of first order system. Okay, if you analyze the first order system, these 6 parameters we get, and we have seen what are the 6 parameters refer to and what is the practical value for first order